So on February 10th, 1990, high tide in Boston was at midnight. The water level at high tide was 9.9 feet. Later, at low tide, it was 0.1 feet. Assume the next high tide is exactly 12 hours later and that the height of the water is given by a sine or cosine curve. Find a formula for water level in Boston as a function of time. So in this question, we need to form a graph and represent that graph as either a cos or a sine graph. I will be doing both. Something really useful to recognize is anytime you're doing sine functions or cosine functions, they pretty much have three values that relate and then one unique value. A, B, and K will always be the same for a function that can be represented as a cos or a sine function. The unique parts is the phase shift, and that's because we go based off of the starting points, which we'll talk about in a bit. That being said, we are going to determine A, B, and K first due to the fact that these are the easiest to determine. Now, whenever you're given a word problem, it's usually best to try and form the graph of what it looks like and then form the equation based off that. Usually the easiest variables to determine are A and K. A being your amplitude and K being your midpoint. That's because these two things are both determined using the max or min points. Now our question here tells us that we have a high tide of 9.9 feet. That is our maximum. It also tells us we have a low point at 0.1 feet, or a low tide, which would be our minimum. So our max points equals 9.9 feet, and our min point equals 0.1 feet. Now, understanding the equations that allow us to use these values to determine amplitude and min point are very useful. Amplitude, which is A, equals max minus min dividing by 2. So that means 9.9 minus 0.1 divided by 2 will equal 9.8 divided by 2. And 9.8 divided by 2 gives us 4.9 feet. So we have an amplitude of 4.9 feet. So we will keep that in our back pocket until we start graphing. Now how about K? K is our midpoint. Anytime you're finding midpoint, it's the sum of two numbers divided by 2. So our midpoint here is between our max and our min. So that would be the sum of these two numbers, so max plus min, divided by 2. So 9.9 plus 0.1 divided by 2 gives us 10 divided by 2. So that means K equals 5 feet. So now we have our midpoint and we have our amplitude. So we can start roughly graphing this thing. So I'm not going to do any negative x-axis. That's because we're working it in t hours. Okay, so it's our function of time. We can't have negative time, so this negative doesn't matter. Our minimum is 0.1 feet, and our maximum is 9.9 feet. And again, that's from our high tide and our low tide. Let's maybe make that look a little nicer. I'm going to give titles to these axes. So this is height of tide, and that is measured in feet, and this is time, which is measured in hours. Now recognize we're not doing like a 12-hour clock, okay? We're not doing 1 p.m., 3 p.m. We're doing kind of more army time. So this is 0 hours, which is also known as midnight. And then we'll just be increasing. So we'll be going to 6 hours, 12 hours, 14 hours, so on and so forth. We also have our midpoint, which we know is 5 feet. So we can draw a rough line, just lining that out for us. And recognize that our amplitude here, which we figured out to be 4.9 feet, is true. To get from 0.1 to 5, that's 4.9 feet. The distance between 5 and 9.9 is also 4.9. So there's our amplitude. So we already have a few values that we can plug into our equations if we're forming this. We have A and we have K, and remember these are the same regardless if you're dealing with cos or sine. Now the other one that they have in common is B, which is tied to the period of what is occurring. Now whenever you're dealing with real world problems or word problems, when you're trying to graph or form an equation, your y-intercept, okay, is usually either a maximum, a midpoint, or a minimum. Not always, but 90% of the time it's useful to graph it, saying that's where our y-intercept is. Now if we read our question again, it says high tide in Boston was at midnight. That means we're at a maximum at midnight, which is 0 hours. Remember, our maximum is 9.9 feet. So that means when we're at 0 hours, we're at 9.9. So our y-intercept is a maximum point found here. So this is 0 and 9.9. Now, if we want to start determining what B is, we have to determine what the period is. And remember, the period equals t. The reason we have to figure out the period is because we can figure out what B is by the relationship of 2 pi over t. Now, if we go back to our question, it tells us assuming the next high tide is exactly 12 hours. Remember, maximums and minimums repeat for the period time. So if our next high tide is 12 hours, that means our next maximum is at 12 hours. So we could maybe write this as 12 here, 12 hours, and we have a maximum point there. So there is 12 and 9.9. Another 12 hours after that, which would be 24 hours, you're going to get another maximum. So now we have a few points plotted. Something really useful to understand is midpoints, minimum points, are directly in the middle of two adjacent max points. So midpoints, or minimum points, are at the midpoint between two repeating maximums. Okay, so that means our midpoint between our 0 and 9.9 maximum and 12 and 9.9 maximum will be directly in the middle of 0 and 12. So to find a midpoint, it's always the two numbers that you're determining. So let's say x1 plus x2 and divided by 2. Okay, you can kind of think about that in terms of how that relates to finding your midpoint for k. So we want to find the midpoint between this maximum and this maximum. So 0 plus 12 divided by 2 gives us 12 divided by 2, which is 6. So that means our midpoint will be found at 6 here. So we have a point here now, which is 6 and 0.1. Now recognize min points or minimum values occur for the period. Okay, so we know our period is every 12 hours. So our next minimum will occur 12 hours after 6, which is 18. So here we have 18 and 0.1. Something kind of useful to kind of notice is we could also find this using our midpoint equation. So 12 plus 24 divided by 2. 12 plus 24 gives me 36, and dividing that by 2 gives me 18. So you could also determine it that way. Now at this point, whenever you have your maximum and your minimum values, you can now roughly form the equation. Okay, so we're going to go down, go up, and repeat this process. So now you can see that we're starting to form a nice cos or a sine function. Now we have A, we have K. How do we determine what B is? Well, B is simply related to the period. Remember, the period in this case is every 12 hours. Okay, your maximums, your high tides repeat exactly 12 hours apart. So here, B will equal 2 pi divided by 12, and you can now simplify that to pi over 6. So B equals pi over 6. So let's write out our equations that we have so far. If we were to write it in a cos function, it would be y equals A, which we figured out was 4.9, cos B, which is pi over 6, x minus h plus 5, which is k. If we did it for our sine function, it's going to be the same thing, simply with sine. 4.9 sine pi over 6, x minus h plus k. Now at this point, we can start solving for those phase shifts. Now remember, phase shifts, so that h value is unique depending on your sine and cos. There's infinite amount of h values that we can put in here, but we'll talk about that right now. So in order to figure out what the phase shift is, we need to know what our base functions look like. So our base functions, what I mean by that is, what does y equals cos x look like? Okay, and at this point you should understand what these look like. Cos x starts at a maximum of 1. Okay, so we just need the rough idea of what cos x is. Sine x, starting point, what I mean by that is your x-intercept, or sorry, your y-intercept starts at the midline. So right here. Now what we're going to do is we're going to look at our new equation and figure out, okay, where did our starting point shift to for cos x, and where did our starting point shift to for sine x? Let's first focus on cos x. So remember, cos x starting point is a maximum. Where did that maximum go? So if we look up here, our maximum never actually moved. Our maximum here has stayed, and our y-intercept is still a maximum. We could also use this maximum as a phase shift. We could see as if cos shifted 12 units to the right. So we could either represent cos as if we had no shift at all, so simply pi over 6 times x plus 5, or we could see as if our starting point here moved 12 units over to the right, so because of this here. So that means we could also represent this as y equals 4.9 cos pi over 6 x minus 12. So there's two solutions there, which will graph the same equation in terms of cosine. Now what about the sine function? Well, sine function, our starting points is at the midline. So we have to find midline points on our equation and figure out how far it is from the x-axis or the y-axis. So here we have a midpoint, but that midpoint doesn't quite work, because recognize on our base sine function, our starting point, as it goes to the right, it increases. Here it decreases. You could still technically use this midpoint, but you would have to apply a reflection, which I won't be doing here. So this midpoint doesn't quite work without reflection. So what I'm going to use is this midpoint. If you can kind of compare it to our sine function here, this midpoint would have simply moved over a few units. Now we have to determine what those units are. Okay, so for this, how do we determine what the x coordinate is? Well, it's useful to understand that midline points or midline intersections are directly between the maximums and the minimums. Okay, so to determine what the x-axis here, or the x-coordinate here is, we're finding the midpoint between, so b/t is just between 6 and 12. Well, remember, we just talked about how to find midpoints. You add them up and divide by 2. So 6 plus 12 divided by 2, that will give us 18 divided by 2, which equals 9. So this point here is 9 and 5. Since it's on the midpoint or midline, you know it's 5 feet. So that means we could have seen our sine function shift over 5 units to the right. So now we can write that in our equation. So if we shift 5 units to the right, then we'll have x minus 5. Or sorry, not 5, my bad. It'll be 9 units to the right. I was looking at the y coordinate, but we're talking about the x coordinate. So 9 units to the right. So we have shifted 9 units to the right. So now we can plug those in to our equation. So y equals 4.9 sine pi over 6 x minus 9 plus, I forgot to put my k value here, which is okay, which is simply 5 because that's our midline. So I hope that was helpful. Again, let's maybe look at how would we represent it using this midpoint. Recognize that's a reflection in the x-axis, okay? So if we want to use this midpoint here, it would be, well, first we have to determine what the x-coordinate of this is. So that would be 0 plus 6 divided by 2, 6 divided by 2, which simply equals 3. So this point is 3 and 5. So we could see this as if it was shifted over 3 units right, but then reflected in the x-axis. So in order to apply an x-axis shift or reflection, we have to put a negative value on a. So negative 4.9 sine pi over 6, and then we shift 3 units to the right. And that would be our solution there.